Have you ever thought what are VMs, containers, and Kubernetes all about? Let's find out in this video. Firstly, let's take a look at what are virtual machines. VMs are a technology for building virtualized computing environments. So they have been around for quite a while and they're considered the foundation of the first generation of cloud computing. So looking at the architecture of virtual machines, we can see that the infrastructure forms the foundation of everything. So here we are referring to the physical servers, so which can be residing in a data center, for example. So on top of this infrastructure, an OS is running. So operating system runs on top of this server. And then we have something called the hypervisor. So this is a very key component which helps us to virtualize the infrastructure and dedicate and allocate the resources to the various virtual machines they're going to run here. So each of this is a virtual machine which is being run on top of a operating system. So we're going to call these virtual machines as guest operating systems. So here we're able to actually allocate various number of cores and the RAM, etc. through the hypervisor, and we have various different applications which are running on top of the guest operating systems. So think of this as that we are actually emulating a guest operating system on top of a real operating system. So each of this operating system is acting as an isolated environment for different applications to run within it. So by creating a virtual machine, we have actually sandboxed this environment for the application to run in. So this is the traditional way of how institutions have actually various dedicated operating systems for different purposes through a VM. So for example, one of the guest OS might be actually powering a database server. So another example would be how AWS EC2 instances work. So they work in the exact same way. So Amazon is actually able to pull together all the infrastructure that it has of the servers, and when we request for a specific instance type, it actually creates a virtual machine which runs on the physical host. So this concept of pooling infrastructure together and then virtualizing that is very powerful, because to develop an application, to deploy it, I do not need to purchase the infrastructure and set it up myself at all. I simply need to request and rent the required resources in the form of a virtualized environment, which is an EC2 instance from Amazon Web Services. Next, let's take a look at what are Docker containers. Firstly, containers are a lighter weight, more agile way of actually handling the virtualization bit. So they do not need a hypervisor, and the main difference you would see in the architecture is that instead of a hypervisor and a guest operating system, all we have is something called a Docker engine which powers different kind of containers. And think of containers as a sandboxed environment where your applications run. And since they do not use a hypervisor, we can actually enjoy faster resource provisioning, and usually your applications are available faster. So rather than spinning up an entire VM, containerization actually helps us to package everything that we require. For example, here the libraries, the binaries, which are required for the application to run. All of this is packaged together as one container. And because we do not have a guest operating system, only the libraries and binaries that are very necessary for application to run is bundled together, and that keeps our containers very lightweight. So why containers over VMs? So firstly, it would be development efficiency. We can package our apps with the exact version of the libraries and dependencies to be run on a specific operating system. So many times you would have experienced this issue of where you are using a different version of runtime or a particular dependency as compared to your team or a colleague, right? So those kind of discrepancies can be avoided with our containers, because all we need to do is to create a simple Docker file with the instructions on what the app requires to run and how to run the application. So because of this, our application is lightweight. Without a full-blown operating system, we just package only what is required. And of course, there's going to be lesser management overhead, because there's going to be less bug fixes, patches, and maintenance that you've got to do. So it all comes down to these two concepts of flexibility versus portability. So this is a good way to think about VMs and containers, because VMs offer us the flexibility and containers offer us the portability. With VMs, we have the flexibility of hardware because we are able to customize and allocate the resources. For example, the number of cores, the RAM, etc. We can have exclusive control on that and on how we can allocate or deallocate that. So with containers, we get the portability all specified in a single Docker file about the runtime, libraries, dependencies, etc. So anyone can use this single file to set up a replication the exact way that it should be run with all of the specific versions of the libraries, dependencies, everything specified. So next, let's take a look at what is Kubernetes. So Kubernetes is a container orchestration platform. So this is an open source solution to manage containerized workloads and services. It's really useful for running distributed systems because it helps us to ensure the resilience of our system through the scalability and failover mechanisms it provides. So why do we need Kubernetes? Moving from a monolithic architecture to a microservices-based architecture, we needed a way to deploy these various microservices and scale them. And Docker containers provided an effective solution. We can have multiple containers running with the Docker engine with the correct and intended configuration. But think about these questions. How do we actually upgrade containers or perform debugging without any downtime? How can we actually communicate across our Docker containers effectively? How do we actually manage them? So this kind of overhead and this kind of complexity can be solved with Kubernetes. So it provides high availability, which means no downtime. It offers scalability and provides failovers and disaster recoveries as well. So this is how the overview of a Kubernetes architecture looks like. We have the masternode, and on the masternode we run Kubernetes processes. So basically Kubernetes is abbreviated as K8. So we have K8 cluster services which are running in the masternode. So mainly there's 4 different services that you need to know about. One is the API server. So this is the entry point for the Kubernetes cluster. Our API server helps us to determine if a incoming request is valid, and then it processes that. The scheduler is in charge of scheduling containers on different nodes based on the resource available and what is required. For example, the CPU, the memory, etc. So a controller manages and takes care of running the cluster. And we have something called etcd, which is a key value storage of the config data, the status of our different nodes, everything lies in etcd. So this is a fault-tolerant and distributed database, and it is the ultimate source of truth. So below the master node, we have different worker nodes which are connected to it. So in each worker node, we have something called a kubelet, represented by this K here. So this kubelet is actually a Kubernetes process that communicates with the master node. And each worker node has different pods. So a pod is actually the smallest unit of deployment in Kubernetes. Each pod can have one or more containers running within them. So here we have also specified the replica. So replicas specify how many of the pods we want running. So pod 1 has different replicas. So this is replica number 1 and this is replica number 2. And to put it all together, how it works is that all we need to do is to create a deployment YAML file, which is a configuration file that specifies the various pods that I need and how we should configure them. So pod number 1, here I've configured that container A and B needs to be inside pod 1, and I need 2 replicas of this pod. Similarly, I've told in my configuration that I need container C to be in pod 2, and it needs 2 replicas as well. Now I will feed this deployment.yaml file to the API server. So what I'm doing here is to basically tell the API server that use this deployment configuration file. This is the desired state for my application cluster, and use this and create and run and manage the cluster for me. Now this master node will actually take this configuration and then it will spin up the various pods and replicas required in the worker nodes. So here we have A and B containers running in pod 1 and we need 2 replicas of the pod. And here we have configured pod 1, this is replica number 1, and pod 1's replica 2 run in this second node. And similarly, pod number 2 has container C which is running, and it has 2 replicas. And that has been configured here, and replica number 2 is in the third worker node. So containers A and B are running within pod 1, and container C is running within pod 2. So when a worker node fails, for example, this worker node fails, this will be actually communicated back to the master node, and it will realize that there is a gap between the current state of the cluster and what is actually required. What is actually required is specified in this configuration. So this gap will be fulfilled by actually creating this pod in one of the other worker nodes. So that is how failovers or disaster recovery works. So here's a small recap. We saw that virtual machines offer us the flexibility of more resource allocation, but there can be more overhead associated with configuring and managing these VMs. And containers offer great portability of application, and we get development efficiency. Finally, we also saw what is Kubernetes at a high level. We see that it orchestrates large complex applications, especially ones with microservices, and it helps us to power production-grade deployments with a focus on scalability, resilience, and disaster recovery. So I hope in this video you learned more about VMs, containers, and Kubernetes, and how they help us to develop and deploy applications more effectively. If you found this useful, be sure to give me a thumbs up and do subscribe to the channel for more upcoming content. Thank you.